My name is Yael Weiss, and it sounds like everyone here in this room remembers the day that Amber called them. I don't remember the day, and I can't find the first email I received from her, but we did connect in LinkedIn in October 2019. So that's like a big moment. Amber connected with me on LinkedIn. So I'm a CEO of a small biotech company that focuses on rare genetic diseases, neurodevelopmental. And I'm happy to support Amber with her efforts. And really, I'm amazed by everything that I heard today. This community has come so far and done so much. And I know for the parents, it feels like it's really slow, but in drug development years, it's actually lightning fast. So you should be very proud of yourselves and what you achieved with your fundraising and with Amber calling people. So you did great. Thank you. So as the day went by, I jotted a few questions for each of the speakers, and I'd like to go from diagnosis. There's somebody here from GeneDx? Oh, hi, yeah. So from diagnosis to preclinical to clinical, if you don't mind. But please use the opportunity to ask questions, because I'm sure there's a lot of stuff that you want to know and want to ask, especially parents. I'm from Israel. There is a saying in Hebrew, hit the expert, so hit the experts, okay? Well, don't punch them, though. Softly, exactly. So maybe start with diagnosis. We heard how important diagnosis is, and I think about it all the time as working in the field. How do we help these small communities get larger? And it's on many levels, right? You have a child that has some neurodevelopmental issues. You want to get a diagnosis as fast as possible, but also there are a lot of families out there that have kids that are older. Maybe they had a genetic test, but at the time, SLC6A1 wasn't on the panels or exomes weren't done yet. How do we reach these populations?
Hi, everybody. My name is Liz Butler. I'm a genetic counselor at GeneDx, and we are a laboratory that offers genetic testing for diagnosis for rare disease. One of our areas of focus is neurodevelopmental disorders, and so we have panels for epilepsy and autism. But over the last 5 to 7 years, I would say, we've really transitioned to offering a lot of exome and genome sequencing. And so I think we think a lot about this question of how to reach these families who maybe their children were growing up at a time before we had panel testing or exome and genome sequencing, and before the SLC6A1 gene was discovered. So I can give you an example. In our laboratory, we started offering epilepsy panel testing in 2012. At that time, the SLC6A1 gene was not known to cause epilepsy or autism, and so it wasn't included in the early versions of our panel. The first publications that really connected SLC6A1 to epilepsy and neurodevelopmental disorders in humans were in, I think, 2015, and we added the gene to our panel shortly after that. So we know just within our own laboratory that we have families who maybe have children who were tested in those several years using a panel that didn't include the SLC6A1 gene. So I think there are definitely efforts ongoing now to really try to educate adult neurologists about the importance of genetic testing in adolescents and adults with early onset neurodevelopmental disorders. There have been a number of publications that have come out about this recently that have shown even in older individuals that it can have a significant impact on treatment. And so I think there are a lot of efforts to try to continue to educate, but I'm sure that there are many people in their later childhood, teenage, and adult years who have SLC6A1 or other rare diseases that just haven't been diagnosed. I think we heard about some of the barriers to testing. There are a lot of efforts to, first of all, try to increase insurance coverage for genetic diagnosis. I think this was highlighted as a big source of frustration for some families today. We have a big team that works on this in our payer relations department, and I know that there are other companies doing the same, and having the guidelines certainly is helpful, and trying to expand access that way. There, I think, also are efforts to educate providers about the importance of doing this testing early, and I think it's better once, if you have early onset seizures, but I think that where we still see a lot of gaps and delays in diagnosis are in the sort of period before seizure onset or in patients with neurodevelopmental disorders that don't have seizures. There tends to be kind of a longer diagnostic odyssey there. So I think there's a lot of work to do in those areas still, and a lot of education.
And how can SLC connect and the parents here help you if they can?
So, I think the education efforts from the group are really important. And we heard stories from so many of you who've, worked with clinicians and told and shared your stories. And I think that's incredibly important and really powerful. You see how many people on the stage have talked about learning about or getting connected to SLC 6A1 because of collaborations or communication from Amber and others. And so I think that that's incredibly important, sharing the stories and really, trying to continue to talk about the importance of the diagnosis and the many ways that it benefits you as a family and has benefited your children. And we're certainly, trying to do this on our end as well, and are happy to continue to collaborate with organizations like yours to see how we can do this more moving forward.
Kim Goodspeed from This Morning. I'm one of the child neurologists, and one thing that I find frustrating or disheartening is when I hear your stories that your developmental delay wasn't picked up, and I see a lot of nods across the audience. And I wonder, and Amber, we can talk about this, if there might be an opportunity even to get to the root of that, because if you can't even get past that first gate, it's hard to even get to the specialist who orders the test in the first place. Some states allow for self-referrals to ECI and some early childhood intervention, so that's the program that's in place for kids under the age of 3 years who have developmental delay. And it gets you at least connected with therapists who then can continue to say, yeah, there really is something wrong, or mom and dad were right that not sitting at 9 months isn't normal. The other thing that I think could be exciting is these programs like Baby Deer, Baby Bear, hopefully Baby Dillo, if that ever happens in Texas. But the problem with those is that they're only for NICU patients. And you guys don't usually spend time in the neonatal ICU. Y'all usually are healthy babies that go home with mom and dad. So I've partnered with Combined Brain and a few others. Terry Jo is another one of those great people who's great at getting a lot of interest, and I see additional nods across the audience that she's a great connector too. Some people just have that gift. And one of the projects that they're trying to do, and I've been helping with, is a project Find Out. And the goal with that project is that we can capture kids that are in a pediatric office. And it doesn't have to be a physician referral, it could even be a parent referral. So if you happen to hear about the program, think your child might fit the criteria, which are pretty simple. Low tone and delayed milestones would get you there, which you guys often have very early, and that would get into whole exome or genome sequencing as part of a research study, just like the Baby Bear, Baby Dillo, Baby Deer programs. But trying to capture those kids that maybe don't have a rip-roaring, dramatic, severe presentation at birth and end up in an ICU. And so hopefully with efforts like this, we can continue to demonstrate that utility and how getting that diagnosis early can really change the trajectory. Maybe we find something, if you get to follow these kids early, if you start seizure medicines early, does that change anything? And even our basic stuff, while we're waiting for the super fancy science to come along, can we change any of the trajectory just with medicines that are available now? So I think any way that you guys can support or spread words or continue to share your stories always helps us make a case. But I think even potentially trying to partner with the big pediatric organizations or your even state pediatric organization and try to tell your story and like, this was not missed by my pediatrician, but maybe it could have been taken seriously a little more early, and try to get at it at a partnership side.
One other thing, just kind of along those lines, that I think moving forward we'll continue to see expansion of is really starting to use genomic testing in the future as part of newborn screening. So you probably remember your baby having a heel stick test at birth, where they're looking for treatable conditions. They're mostly disorders that affect metabolism right now. But I think one of the kind of exciting things on the genetic testing front is using genome sequencing at birth to try to diagnose severe early onset disorders. And so there are some studies that are being done in a research setting now that our lab is collaborating on some of them. For example, there's one called Guardian in New York State, and there are others in other states that are looking at newborn screening in that setting and trying to show the utility of making that diagnosis right at birth, even before a baby might be showing symptoms. So I think there's a lot of improvements to come, but it's going to take a little while until the data is there to support this being offered in a way that is more widespread.
Well, obviously, we can spend all day talking about this, but let's move on to the next. Does anyone have any questions on patient diagnosis to our experts? Yes, there is a question.
I mean, I think everyone knows that the cost of exome sequencing, genome sequencing has gone down like orders of magnitude since the beginning. And I just wonder kind of where it is now, the cost, actual cost. So parents that come in with an issue that would really benefit from exome sequencing, for example, what are the ranges of costs?
Yeah, so it varies depending on a number of different circumstances, but I will say exome sequencing in most cases is covered by insurance. Many insurance companies do have requirements for specific criteria that they want to be met in order to pay for it, but in most cases it is covered. And so in those cases, it's really depending on the insurance plan, what the copay and deductible might be and what the out-of-pocket cost is. I will say our volume, for example, of exome sequencing is usually very high at the end of the year after families have met their copays and deductibles, because they're often able to get genetic testing done without an out-of-pocket cost once they've sort of done that through other options. But most labs offer self-pay prices as well. Genome sequencing isn't covered by most insurances. I think Holly from Illumina showed some information about this earlier. I think you'll continue to see that change over the next few years. For people who are doing self-pay because they don't have coverage for one reason or another, it's usually in the range of a few $1,000s, I would say.
I heard that some companies are offering it for $1,000, so it is going down, and we'll be in the hundreds probably in the next few years.
Would agree.
And then you can order a kit home and just do it at home, probably, right?
Yeah.
Okay, my next question is to Kati, but if anyone has questions to Kati before I hit her, then please ask her. So the Ravicti story is amazing, right? Like, wow. But as a drug developer, I'd love to know how drugs work, right? So how do you decipher how Ravicti works? And can you use the data from patients, the different mutations, who responds, who doesn't respond? Can you use this information to elucidate the mechanism?
Thank you very much. That question is really a $1 million question. My son actually asked me. Yeah. So we have looked at this drug for over 10 years. So what I want to let you know, my background is from single-lane transduction. So I did a short postdoc for neurodegeneration. So I'm constantly follow up all this paper published in neurodegeneration field. So I know this compound. Also, I'm from clinic. So I was trained as a clinician, 100%. So I really care about the outcome, improve treatment. So I aligned a lot disease mechanism, since I was 17. So I kind of start with in China. So I look at that. And now,
18 now.
yeah, I started work in hospital as a 14, age 14. So that's why I have a long history working in clinic. So that I know patient very well. So because the reason I become neurologist and I come to America as a scientist is that I feel a lot of drug is not working in clinic. When I work in ICU, I have handled over 100 patients died in my hand because I saw a lot of, it's not a responsive, a lot of drug. So I feel probably we should need a better drug. And I later on become neurologist. This is why you see the picture, my mentor. And I feel that's just too much. How can you get a new drug? And I start to look at the genetics. I think very early on, I wrote a review article in Chinese, published in China. It's about the ion channel and the epilepsy genetic mutation. That thing really excites me. So I feel here you have a very clean background you start with. So when I was like a teenager, so I can kind of start to follow up on this one, and then later on I become epileptologist in China, and then come to America. I first work in like Wednesday in neurodegeneration. We looked at all kinds of signaling pathway. So my mentor was Dr. Mace. He said, no matter what you do, like what we see in clinic is a symptom. No matter you call it Alzheimer's disease, epilepsy, Parkinson's disease is a symptom. So we define the disease that way, but it's one brain, like one, so different kind of cells, but fundamentally, you probably have a lot things in common. So I really, that thing really inspired me. So I look at a lot, very hard on a signaling pathway. Also, when I was in Wednesday, I'm the one in charge of what is the cell maintenance. I cultured neuron, astrocytes, microglia from same right, like to just all kinds of cells. So kind of play around with a lot. And then when I come to Vanderbilt, work as postdoc with Dr. McDonough, he's totally different approach, use electrophysiology. And then, so I think that's just one way. You have many ways to look at a disease, but that's one way. So I start to look at the trafficking. So you say, okay, right now we have a gamma-2 mutation associated with fibrous regions, have a Dravet, and gaps. So what causes that difference? What causes like a severity of disease? So then I look at a truncation mutation, and I found that mutation form a lot of aggregates. So because we all know what is a neurodegenerative mutation, aggregates. So first, Dr. McDonough did not believe me. So until we use pass cheese, and we see 5 minutes after we start to pass cheese, and you see clear dimer, and that aggregates. So we follow up like deeper biochemistry, and then we're convinced. So this is epilepsy mutation, but it's very rare. And later I look at many. So it's different level. Some maybe form aggregates, some do not form, but they all get inside in the ER. So this is why we look at a lot inside the ER. But for phenylbutyrate, because one side is hydrophobic, one side is hydrophilic. So when you put it into cells, they're going to bind with your mutant protein. So kind of smooth up so they can traffic it. So whole time when I'm in America, I'm working, I call my lab as a kitchen. So that's why I look at trafficking.
So based on this theory, different mutations will form different type of aggregates or not form aggregates at all. So is this like, can you screen patient cells before you administer the drug to predict whether they will respond or not?
I think so.
Yeah.
Yeah, I think you can use patient cells with different mutation. You can see, especially for GABA transporter. I think what in lab we are doing, I think pretty accurate. We can see the difference. However, one thing, because in vivo, we also notice the difference between in vivo and in vitro. So we cannot say 100%, but I think to a certain degree, it can be predictable. Yeah.
Thank you, Kathy. Any other questions on Ravicti? I'm sure you want to know more about it. It's fascinating. Steve has a question.
Yeah, I want to, I mean, do you think that the mechanism, because you were showing that you're getting upregulation of the wild type allele, or the wild type protein, I mean, do you think that that's the mechanism, or is there something else that's going on as well?
So I think upregulation of whatever definitely is one mechanism. I think that's very encouraging because all the SLC1 patients are heterozygous. You will get a wild type allele, but the mutant allele is going to be very interdependent. Yeah, so we have tested, we published 8, we have a look at more than that. Like some mutant alone, you actually did not see any upregulation, but if you put them together, you see upregulation. So that means no matter what, you can get some benefit.
Any other questions on Ravicti? So I'm moving to Steve. Is that okay? The results of my studies that you presented were, as you said, promising on one hand, but not so on the other hand. So just can you give us a general description of what you're planning to do to change this? Is it because it's overexpressing, do you think? What's the reason that mice are dying, and how can you, what are the different paths to check if that's the reason and what the solutions are?
Yeah, well, yeah, and I apologize that the images that I was trying to show were kind of washed out, and it was really hard to see them. But I mean, we know from the mice that we're expressing the gene in a lot of cells in the brain that don't normally express it. So I can't say that that's the problem, but it's, you know, it's a smoking gun a little bit. But I think that overall, we're working with constraints right now where we just don't know. Like we don't know at what point we can restore the gene and what benefit that's going to have. You know, I mean, it could be that we just have to restore the gene really, really early in development for it to have an effect. We want to hope that we can restore it later, you know, in juvenile mice or adult mice, and that it'll have a good effect, but we don't know that. And there's kind of work that's been going on in the background in the community to try to make genetic mouse models that are basically born without SLC6A1, and then we can just turn it on in all the cells. And it's like it's an artificial kind of genetic trick that we can do in mice, but it's a tool to answer that question. And if we were going to do this slowly and carefully, we would do all that work over years in the mice before we tested a gene therapy. But, you know, we wanted to jump into
But
it.
then you got a call from Amber.
Yeah. And we said, well, no, we'll take a shot. And, you know, I think we have things there that are really promising that we're excited about, for sure. But, you know, we've got to refine it and we've got to make it better. And I think that we have some avenues to play around with that, to try to control where and how it's being expressed. We've done complex designs for other genes like Rett syndrome where you know, we've made breakthroughs, but unfortunately it takes time.
So in a different conference, I heard about brain organoids. And for the audience who may not know what brain organoids are, they're made out of human cells. They can be made from patient cells and their parents. And these are little mini brains in a plate that could be used potentially to screen drugs. Do you think you can use organoids to screen different constructs and then take the right one into a mouse instead of waiting for the mouse to breed and mature?
Yeah, I mean, I get that question a lot, and I don't know how to answer it. I'm still trying to figure out. Yeah, the organoids are really cool. They're really exciting. There's a lot that you can do with them, but I have trouble figuring out how they're going to be relevant when we're testing a gene therapy approach. Because a lot of it's all about delivery. You know, we don't deliver the gene to every cell in the brain. We deliver it to only certain cells. And so I don't know what, you know, when you do it in an organoid, I don't know.
Different regulatory, I don't know.
You know, and if you're controlling copy number or not and things. But
just a thought.
Yeah.
Thank you. Any questions?
Actually, I have a question for Stephen. So I wonder how many titers you tried for the virus, like the AA virus. How many titers you tried?
We've just tested 2 different designs. That's
So and right now in lab we have investigator Carson. He's doing dual therapy. So we try to rescue with gene restoration plus PBA, because this way can reduce the dosage of gene therapy, reduce toxicity. So if there's something.
Yeah, I mean that's a possibility too. Sorry, he's trying to ask something. You can yell. I can hear you.
Test.
And I'll read what you did.
Yeah.
Oh, there we go. Thank you. No, I was really impressed by Dr. Calvinell's report that in the heterozygous knockout mouse with a 40% decrease in the GABA transporter, there's a very significant phenotype, and Dr. Kang's work as well, that there's an aggregation, a potentially toxic gain of function. So it seems like natural regulation of GAT1 is extremely important, as I think you're suggesting too as well, even along the neuronal membrane itself, whether the transporter is under the synapse or more ectopic. Normally the neuron makes these decisions, but of course a transgene like a cDNA would be generally ubiquitous in terms of a lot of these properties. So I have a question for Dr. Gray, and that is, similarly, how do these animals die, and to what extent do you think really one can correct, given such a small perturbation in GAT that creates a very significant phenotype? If not only if the gene is ectopically being expressed where it's not normally expressed, but also in levels that are much harder to control, do you think that this approach is viable?
Well, we don't know that yet because, I mean, we used fairly gross, we can call it crude tools at this point, with the design, and it was the best shot based on our experience and based on what we knew here, 3 or 4 years ago. But, we've gotten into much more complex designs of, like, around Rett syndrome, where we've designed cassettes to sort of self-regulate things like MECP2 that are extraordinarily dose sensitive. But all of that takes more time and it takes development. This was just sort of the first pass where we were trying to take a shot at it.
Yeah, I would suggest that the issue you raised about the potential toxic gain of function is super important, because if there really is one, then adding more protein isn't going to protect against that. It actually could make it worse. So I think thinking about a gene therapy approach that mimics the natural, or takes advantage of the natural regulation, so the right gene is expressed at the right amount, in the right place, letting the cell take care of where all these things take place is going to be hugely helpful. Because we've already seen it's a very sensitive preparation in the first place. So if it's very sensitively produced with a heterozygous manipulation, then you can now argue that it's got to be a fairly precise correction as well.
Thanks. Kat, I don't want to put you on the spot, but do you want to say something? Kat Meyer, is there anything you want to contribute to the discussion on gene therapy? But if not, it's okay. Okay. Maybe. Amber, can you give her the mic?
She said no.
Oh, she said no? Okay. She's a very quiet no. Okay.
I was wondering, because you mentioned making like a conditional gene upregulation where you could try different development time points and see when overexpression could help. Have you also considered using that model for screening different promoters to see if you can find the cell population that would help you get just enough rescue without the side effects?
Well, yeah, I mean, I think the availability now of that sort of conditional allele opens up, I mean, a lot of really important experiments. So, I mean, you could like knock out the gene in every cell except neurons, like have it only expressed in neurons, or you could have it expressed in all cells but not neurons. You can start to answer some of these questions about what cell types are really important and which ones aren't. And I mean, you can get more sophisticated to make models where like you would only reactivate it in neurons. So I think we've got some of the mouse models now where you can design those experiments. They do take a long time because you've got to breed all the mice and and go through rounds of breeding, and there's no way to rush it because it takes a lot of time to do that. But at least I'm excited that those tools are now available to start doing that work.
Thanks. Any other gene therapy related questions from the audience? And I'll move to Michael. Oh, there is a question? Sorry, missed it.
Yeah, this is probably the type of question you would expect from a parent, but you keep saying, like, it takes time. How long might you expect your next conclusive results to come in on, like, the next batch of mice?
All right, well, so I'll just back up in general. So we had one thing where we designed a cassette for a disease, and we took it from first thought about the disease to first patient in less than 3 years. That's the best that we've done. But Rett syndrome took us over 10 years, actually probably closer to, 12, 13 years, because we had to work through a lot of different designs and through a lot of different problems. And Rett syndrome was about as hard as it gets, I think. So
the
I don't
answer
know.
is between 3 and 12 years.
Yeah.
I have another question for Steven.
Okay.
Stephen, I have a really hard question for you. So if a gene at the beginning is very important, but later on when I get older, the gene is not important anymore, can you stop a gene? Like, for example, now you give AAV, a gene therapy. Can you stop?
Okay. Yeah, so that's a really important question. So Caddy asked basically like, once we deliver the gene, can we stop it? And the answer is essentially no. So the great thing about gene therapy is it's one injection and it's potentially a lifelong benefit. The dangerous thing about gene therapy is you can't stop taking the pill. And that's one thing that's really, really important for everybody to understand, is that we have kind of one shot to get it right, and we have to be really, really, really careful that we're not doing harm. This is just something for everybody to consider.
So this leads me actually to what I was going to ask, another comment, okay.
And
There's another question.
there's a
too.
lot, sorry. The other thing I would say on the one shot to get it right, but we also don't want to get it wrong and go with the wrong treatment to the FDA and have the entire program fail, because that one treatment wasn't the right one. So that's why it's super important that Steve and others that are working on this are very cautious and thoughtful and have every single duck that could be potentially in a row perfectly lined up, because you just don't want to go with the wrong thing either.
And there's another question in the back.
So, besides fundraising, what can we as parents do to help get closer towards gene therapy? Besides like questionnaires, is there anything else that we can do? Because I know fundraising helps with more scientists and research and cures. And is there anything specific that you're like, if these parents knew, because we are ready, like if there's anything that we're missing?
Yeah, I mean, a lot of it is like we can come up with a lot of ideas, but there's only a certain amount of stuff that we can move forward in parallel. A lot of it's just, kind of resources, people, and, bandwidth. But I think what Amber's already done as far as SLC 6A1 trying to support.
Yeah, 2 weeks ago, the FDA held a listening session with parents and patients on gene therapy. You can go to the FDA website and listen to it. It's actually fascinating. And the input from the parents has been very clear. The risk that they're willing to tolerate is very different than maybe a diabetic patient taking a pill. So the FDA has to take this into consideration. And the second thing was, and this is something that I was going to ask Michael about, and maybe Kim as well, the FDA is asking for placebo-controlled trials for gene therapy, and parents said that this is going to be a very big obstacle to enroll in clinical trials because not many parents are willing to enroll in a trial and know that their child is not getting the therapy. So besides what Steve said and what you're doing already, making sure that those who have to approve the drugs know what you think about it. So you can actually comment. If you go and listen to this session, it was 2 weeks ago, if I'm not mistaken, and the docket is still open, and people can go in and post their comments. So if any of you is interested, go ahead and listen to it and post your comments there. Yeah.
Let me just make a comment on that issue of entering a placebo-controlled trial, because I realize that this is a very difficult decision for a parent to make. But you have to realize that the only time we do placebo-controlled trials is when we don't know if the treatment is going to work. And we also don't know, as Steve says, whether the treatment is safe. We can do the kinds of studies that I talked about in animals, but there's only about a 60% correlation between the toxicology that you get in an animal and what happens in humans. So if you're going into a clinical trial, you have the opportunity perhaps to benefit from the experimental therapy. But if you're in the placebo group, then you're protected perhaps from the dangers of the treatment that might not work at all. Well, that's in medical ethics called equipoise. And in order for a medical ethicist to approve a clinical trial, there has to be equipoise. We just don't know whether the treatment works or not. If we do, then your children will get the treatment.
Yeah, can I maybe also respond to what you asked, what the families maybe can do? And I know a lot of you that are here today already are doing it, and hopefully the committee and speakers will agree to me. But I think one of the most important things is really to participate in the natural history studies and in the registers, so that we can understand, the variability of the disease and have really good documentation on this history of each of the patients. Because how do you prove that a drug is working? It's the same for gene therapy if you don't know the disease progression of the patients that you're going to treat. That's one thing. And the other thing that I'm always really grateful for is if we can receive patient samples, not only blood, but also skin cells that we work with. We make organoids. You've seen a lot of the beautiful work that Kathy also did, and others using the patient samples. So that's absolutely crucial from my point. And just to comment on the placebo trials as well, I think in many cases it might still be worth contributing, because a lot of the clinical trials do have these rollover policies, so that if you were in the placebo arm, you will be promised to then be able to access the treatment at least in a second phase of the study. So it might still be worthwhile, but it is definitely a very hard sell.
And for all of the parents, that's why we're constantly saying, please register, fill out the next survey. It's exhausting. We're so sick of it. We all know. But this is what that data is used for.
Thanks. Great, excellent point.
I know your lab focuses on DNA and gene replacement therapy. Other than like a one-and-done treatment, what would be the benefit of gene therapy versus like RNA treatment with an ASO or something like that? Because you also alluded to it's one and done, so if we don't have it right, it may not be therapeutic or what have you.
No, I think a lot of the ASO technology is really exciting. I mean, and the example is like with spinal muscular atrophy. There's there's more than two drugs now, but the initial two treatments were an ASO treatment and a gene therapy treatment, and both of them, I think, looked really good. I think the gene therapy treatment is like a one-time injection. The ASOs, they're going to have to go back every few months to get a spinal tap and have an injection. But I think it's a little bit of a toss-up right now. I don't think anybody really knows which approach is most effective. But yeah.
And not every disease is amenable to both.
To ASOs,
right?
yeah.
Or to gene therapy. Right?
Yeah. So I would say both are worthwhile to approach, but it depends on the.
If I understand correctly, there are patients that are getting both ASO and gene therapy now. Yeah.
There are definitely some SMA patients who started on ASO therapy and then ended up with gene therapy. They're looking now at combining them even and giving ASO after gene therapy. So I think when we get through this phase, whoever knows how long it will be, I think nothing's perfect in the brain, right? So you're going to probably need multiple approaches. You're probably still going to need some degree of anti-seizure medication for some patients. Just like with Ravicti, we've seen that it fixed pieces of it, but not all of it. We're probably going to need a combination approach for a disorder that's as complex as SLC6A1. And I'm curious if it's going to end up being that some patients even are more amenable to one versus the other, because there's such heterogeneity, such complex disease in all of your families, a lot of similarities in the stories, but so many differences too.
I think the big question is time of an essence here, right? If you can wait till the ideal therapy comes along and it comes in 3 or 5 or 10 years, yeah, wait. But if you want to treat now, and I think as we see more data on CNS gene therapy trials and ASOs, we will know if older kids respond just as well as the younger kids do, then yeah, you have a window to wait. But maybe treating earlier is better. And we don't have enough information at the moment to say one way or the other. Right?
But wouldn't you feel like they lost out on all of this developmental time? And even if the treatment works just as well when they're 13, like life is really hard at 3 years old. And that's just a lost decade for a family, even if there's a little bit of an effect.
I think different families will approach it differently. Some will say, I'm not willing to take the risk. It's still experimental. I want to wait to see that 100 kids got it, and maybe there's something better down the line. And another family will say, yeah, now is the time. I don't want my kid to miss out. I think it's going to be a very individual decision.
So I guess my question is, my daughter's older, so going forward, is gene therapy really going to help her?
I think nobody can answer that question for you right now. That's very unsatisfying, but nobody can answer that question for you right now.
Have they found that anything with the gene therapy or anything that they've done has helped? Do you know what I mean? Like, your body is constantly, as you age, it's devaluating itself. Like, your body's failing in different areas, and as you get older, you're basically decreasing your life. So the older she gets, is it really going to bring back the stuff that she's lost?
Yeah, we don't know. And that would be different for every single gene, you know.
We know from the ASO studies for Angelman, older kids, 15, 16 years old, I think was the oldest child, and they responded to therapy. Not as well as the younger kids did, but they did. And there was a small molecule study on Fragile X in men in, I think, 20 to 40-year-old, and they actually showed some benefits from treatment. Well, had it been different when they were 3 years old? I don't know. We don't have enough information, as Steve said. Yeah.
Is there a correlation between the age of the mice that you referenced earlier and the age of humans? So your mice that were 3 months old had 0 effect, and so we could ascertain that if you're over 5 years old or 10 years old, then
yeah.
I know there's no concrete answer, but if we know it's not working in older mice, then we could have some assumption that it may not work in older children, which is okay. I still think we should absolutely keep curing for the future generations.
Yeah.
But I'm just, I think a lot of parents are asking that question, like, we will never stop for a cure, but what's realistic?
Well, okay. So when we dose a newborn mouse, and a newborn mouse is more of like a late term in utero human, like pre-birth, and so when we treat the newborn mice, there's two things. One, we're treating them really, really, really early, and the other side of that is the delivery of the gene is really, really efficient. So we don't know which of those is more important. Is it that we targeted a lot more neurons, or is it because we treated them really early? And it's probably both. But right now, with the design that we have and the approaches that we've taken, we did not really see a benefit in, I'd say like toddler age mice and in juvenile mice, like sort of, around puberty mice. We didn't see we saw very, very modest benefits. But again, if we're able to deliver the gene more efficiently, and if we had a better design, maybe it would.
Yeah, and I would just add the comment, like, I'm asking only because we want to know what's realistic, but for me, my son may never live independently with a cure, but he may talk someday with a cure, and for me, that would be enough, right? So I think a cure might even mean something different to every family, and so I'll never stop fighting for him to have a chance at a better life, and we appreciate everything you're doing.
Yeah, and look, if we're talking about, ASOs or gene therapy, any kind of gene-based treatment, the way that is we're resetting things, we're giving the neurons, for lack of a better word, we're giving them the potential to work properly. But you still have a lot of connections, and it may be that you really have to pair it with really intensive just occupational therapy,
Yeah,
physical
but this
therapy?
goes to the question
Yeah.
that I meant to ask Kim and Andrea, who I'll let her introduce herself in a minute. Because one of the things that we do when we start working on a specific disorder is we try to understand as much as we can about it, which is why the registries and the naturalists are important. But what we really want to know is what's important to you as a family, right? Is it saying 3 words, 10 words? Is that sufficient? And this is how we construct a clinical trial based on your feedback. So there's no use for us to measure something that's not important to you. And maybe Kim and Andrea can comment on measuring success in a clinical trial. What does it mean?
Sure. Hi. I'm Andrea Mealy. I'm a pediatric neuropsychologist at Children's Hospital Colorado. And I'm so happy to be here today to perhaps bring a tiny bit of a different perspective to my role sitting on this panel. But one of the things I want to make sure that the audience is aware of is that we do have a neurogenetic clinic at Children's Hospital Colorado. We have 9 to 10 providers, and we see 4 different neurogenetic conditions, SLC6A1 being one of them. And so while we're not trying to take over anyone's care, it seems like there's an amazing collection of providers here today, but if anyone is looking to kind of talk to speech therapy, OT, rehab, neurology, genetics, neuropsych, developmental pediatrics, our team has poised to kind of do all of that with you in one day. And if you'd like to come the day before and meet with me for your child to do a neuropsychological assessment, I would be happy to talk with anyone about that. The reason that I think that this is important, again, the neuropsychological assessment is not a cure, but I do feel like we are someone who will walk with you across your journey. And using my data, my hope is always that it will help guide you for kind of what you're trying to achieve for the next 3 months, 6 months, maybe a year, to guide therapies, to guide school, so that we can kind of holistically treat your child and kind of consider and talk about how do we keep them kind of their happiest, but how are we also able to make progress. So I'm happy to talk with anyone if they have questions about our clinic or what we can do. We are participating in clinical trials, and I do feel that as we move forward, neurodevelopmental outcomes are going to be the key players to figure out if these drugs or these gene therapies or drugs kind of are working. So when you're filling out the Vineland again, or the CBCL, or some of these other questionnaires that we've heard about, know that we're working to better understand how those measures work and kind of what works about them, what doesn't work about them. Are there different tools that are better? We're really using these so that we can be ready when it's time for us to demonstrate outcomes.
Yeah, I think one of the really exciting things for me about the gene therapies that are moving forward, whether it's the AAV virus therapies that you heard from Steve or oligonucleotide therapies that were talked about in the Q&A here, is the opportunity not only to affect the seizures, but to affect all of the different dimensions of the disease. And we really haven't had that in the field of epilepsy previously. We've had epilepsy drugs that really focus on suppressing seizures, and there really hasn't been any attempt to develop treatments for all of the other components of this syndrome. We have that opportunity now, but I want to make a bit of a caution, because the regulators and certainly all of you in this room are thinking about clinical trials where you have endpoints that are different from just the seizures, right? The intellectual disability, the movement disorder problems, and all of the other things that we struggle with these developmental and epileptic encephalopathies. The regulators are interested in hearing from you about what you'd like to accomplish, but I would say from my vantage point of many years in the field, I would say be careful what you wish for. We've been extremely successful getting treatments to the market by studying the effects on seizures. And we're not so sure that it's feasible with clinical trials that can be accomplished to demonstrate an effect on these other kinds of components of the disorder. And so from where I sit, I believe that if we focused on a limited outcome of the seizures as kind of an assay, right? A regulatory assay that would allow us to get to the market, then when we're dealing with the gene therapy approaches that we're talking about, we may also see those other benefits. But if we try to get too fancy with our outcome measures, we may throw out effective treatments that ultimately would have benefited our patients. So there may be some debate about that point.
Then you're assuming that you only enroll kids with seizures in a clinical trial then. And we heard that there are kids that did not seize with SLC6A1.
Well, typically what's done is that there are secondary outcome measures. And so we do look at a wide variety of different, metrics. But when we talk to the regulators, and this discussion with the regulators is so important, if you try to throw in a lot of other things that may or may not hit in terms of statistical significance, even if there is a benefit, you have the risk of kind of shooting yourself in the foot. So I just raise that as a cautionary note.
I think we're in a transition period, right? The more therapies go into patients in different disorders, we'll learn more, and what is a secondary endpoint can become a primary endpoint eventually. Kim wanted to comment
I have
as well.
a couple statements. First, how do you ask parents like Amber and myself, who both have children who have complicated seizures? Some doctors would say they don't have seizures, some would say they do, who've given up short of everything to cure them, but they would potentially not qualify because of that. It's a very hard thing as a parent to know that it might be too late because the world hasn't come around to solving problems outside of seizures. That's just like a very hard pill to swallow. And I also just wanted to piggyback on what Kelly said, that I think most families in this room would agree that a 10% improvement in our child's quality of life would be life-changing. So I think we often focus on we need to fix all, everything needs to be perfect. We're not asking for that. We're just asking for better. We're asking for improvement. We're asking to leave our houses. We're asking to send our kids to school. Like, it's one thing would change everything.
Yeah, I was going to say, to counter to Mike respectfully, is that it's hard in this disorder in comparison to other epileptic syndromes because there's such poor consensus on what is seizure in this condition. And I've talked to Scott and Zach about it a lot, and we're still trying to sort out how do we kind of right those two issues, because the kids have spells that look like seizures, but that doesn't always match with their EEG. And I hear it all the time when they come to see me, is that he's had this spell since he was 4 months old. Now he's 3, finally had a drop attack with spikes, and now they're treating it, and it's frustrating. And I completely hear what you guys are saying, and we're trying to sort it out, I promise. My hope is that we can make some sense of the EEG, or at least come to some sort of consensus, have multiple different people who have like specialty eyes, at least on these kids, kind of try to come to a consensus on how do we define it in, like, what is an SLC6A1 spell? Do we just need to call it something different and count those? So we're trying to be creative in that way. I had a second thought. Oh, I know what I was going to say. The other thing I would say is that I think everybody's having pretty strong feelings. It's been an emotional roller coaster of a day. If I can ask all the parents to journal your thoughts. What did you take away from today? What resonated? What didn't? What made you so angry that we said? What was like, yeah, let's go more with that? And a tiny plug for a study we're going to run. We're trying to get the IRB through, but Dr. Bone and I are going to be doing an interview study. So we've gotten some of your contact information, but we want to hear this kind of stuff. And then we can actually analyze those stories and take that in a package with everything else to the FDA to say, these are the things that people care about. Here's the traditional things you guys want to see. Here's the semi-non-traditional things, and here's why we picked the non-traditional things.
Yeah, and I was going to just say, like, as a community, and your community is going to continue to grow, as a community, it feels like the goal is to start a clinical trial. But the goal that's going to help your whole community and everybody, and not a handful of patients, is going to be having an approved drug. And, you know, so, and I've got 3 kids, and I'll fight for them like nobody's business, right? And every one of you should do the same. And, you know, but I think what Mike was trying to say is look for the path. If you feel like you have a drug that works, that can help everybody or help most of the kids, then focus on the path that will get that available to everybody as soon as possible, and not a handful of patients in a phase 1 trial. And that's tough, because that's automatic. When you have a phase 1 trial, it means a few kids are going to get treated and most of them are not. You know, so we want to get to that point where we have an approved drug and then everybody has access to it.
And we don't even know if it works.
Yeah, exactly.
It's not a treatment, it's an experiment when it's clinical trial. I mean, I think if it works, it's a much shorter path. It's an easier sell to the FDA because it's already been approved for something. And then it's just a matter of a company taking it on and seeing that it's financially viable. This coming from an academician, but I've talked to enough industry people that, and had enough of these kind of come through on small, rare diseases.
I think Amber can comment on that because she's liaised with the company that now sells the drug, and it's not, I wish it was that simple, yeah.
So if the drug is already approved, then a physician can prescribe it off-label. There's no restriction to me, for example, prescribing a drug that's been approved for one thing for something else. And well, you know, it's interesting because my assumption would have been that the insurance companies would have pushed back. But the drug that I talked about in my little 20-minute presentation that was recently approved, I've been speaking with the CEO of the company recently, and he's telling me that it's getting approved by insurance companies for conditions that are not CDKL5. And this is a comment actually that Tony made to me over lunch, and that is that the transition from an experimental drug and a drug that's FDA approved is, you can't even conceive of the difference, because there are millions and millions of chemical compounds and experimental gene therapies and so forth that are studied in laboratories. But there are only a few thousand FDA-approved drugs. And it's only the FDA-approved drugs that can be used in medicine to help patients. So once that transition occurs, it really changes absolutely everything. And I completely agree with Steve that our job should be to try to get these out there and proven to be safe and effective to an extent that the FDA is willing to approve them for something. And once they're approved, as Tony says, they can be tried in other conditions. And I think insurance companies, for serious conditions, are considering off-label use and willing to reimburse now. So I would be somewhat optimistic about that. Another thing I wanted to say is I'm hearing from many of you that you're not looking to have a complete cure. You're looking for 10% better, you're looking for language improvement, you're looking for improved behavior and so forth. And I just wanted to make it clear that the FDA is not necessarily looking for a cure we'd love to have cures. I'm not saying that we don't want cures. But that's not the requirement. The requirement is that the drug is effective, that it helps the patient, even if it's only 10%. But you've got to demonstrate that it does help 10%. You can't have a drug that doesn't help the patient at all, and that will not be approved by the regulators. So there's no need to have a complete cure. You can have a drug that benefits the patients, that reduces the seizures, and doesn't completely eliminate them. Now, we'd love to have every patient have the seizures and all the other behavioral things be eliminated, but we don't need that from a regulatory perspective.
Just to follow, because I think that a lot of questions are probably looming of like, if it's FDA approved, we can get it. That has not been the story for Ravicti, which is probably what everybody's thinking about right now. We've tried it, and Amber, I understand, has a pretty entertaining screenshot of how much they told her it was going to cost. We even tried to go through our patient assistance program at Children's to see if they could get it for cheaper and then just sell it at cost, and it still was unreasonably expensive. Now, if it's a generic drug or something that's maybe not as fancy for some reason as Ravicti, maybe, but that one is hard. So I think it's just important.
Don, I just wanted to add, you know, Ravicti has been just to add insult to injury. Like we have kids with a rare disease and we find a drug that works, and of course it just happened to be owned at one point by Martin Shkreli, the pharma bro, who got in all the trouble with the Wu-Tang Clan, whatever, and went to prison and hiked the price of meds, and the drug is $800,000 a year. Like, that's very annoying, and it's super, super bad luck, but it's also why the patient organization is working on a different route, particularly with this gentleman right here, to create a drug that is available and affordable to patients. But there are other instances where I can think of two off the top of my head. One, Paxil worked for a really rare disease, and you just wouldn't know that unless you did a repurposing screen. And we have a lot of people here from the University of Alabama that actually are testing, will be able to test drugs in zebrafish, like zebrafish from PetSmart looking zebrafish. And secondly, for some mitochondrial dysfunction diseases, Viagra works. And I mean, send a guy in, give it a shot. You know, like those are really, really cheap and easy ways to try.
The way the pharmaceutical industry works is they look at the number of patients they're going to treat and multiply it by the cost of the drug and come up with how much money they're going to make. As a patient group, and all the patient groups that Ravicti works for, you're adding X number of patients to their potential revenue. So maybe if they redo their calculation, they can say, okay, now we have 10X more patients and we can charge 10X less for the drug. So that's also something that we need to work on hard to do, to convince them.
Which is why we need more patients diagnosed.
Exactly. More patients diagnosed
And more patients involved.
Exactly, yeah.
It all comes around.
I think we can wrap up now.
Oh my gosh, what a great panel discussion. Thank you so much.
Yeah, amazing. Thank you very much, everyone.